Hello everyone. Today in this video we are going to study about the application of operational amplifier as a adder, subtractor and a voltage follower. When we come for the voltage follower, or when we come for the summer, or when we come for the subtractor, those are nothing but the application of the operational amplifiers. Now let us begin with a summer circuit. When do we call our operational amplifier as a summer circuit is when we find more than one number of voltages connected to a single branch of the inputs. Again, here my input can be connected either to the inverting terminal or to the non-inverting terminal. If the inputs are connected to the inverting terminal, we call this as an inverting summer, and if the input is connected to the non-inverting terminal, we call this as a non-inverting summer. More than two or more than one voltage would be connected to the same input or input terminal. We call such a circuit as a summer circuit. The summing amplifier is another type of operational amplifier circuit configuration that is used to combine the voltages present on two or more inputs into a single output voltage. If more input resistors are added at the input, each equal in value to the original input resistor, this operational amplifier is called as a summing amplifier or summing inverter or even a voltage adder circuit. Now let us see what is the output voltage across my summer or adder circuit. So from the virtual ground concept, we know our VA would be equal to VB. Now what is your VA and VB? VA and VB are the nodes that is represented here in the circuit, A and B. So the voltage across these nodes are called as VA and VB respectively. Okay. From the virtual ground concept, we already know VA would be equal to VB, right? So that is what is substituted here, which should be equal to 0. Now what is the total current that is present here in the circuit? I can say my I1 plus I2 plus I3, sum of the currents entering the loop would be equal to the leaving the loop. So IF. So my IF would be equal to I1 plus I2 plus I3. Now let us find out what are the values for these currents that we have found, that is I1, I2 and I3. When we go for this, for I1 we know it is V1 by R1, I2 V2 by R2, I3 V3 by R3. And what is my IF? IF is nothing but V0 by RF, that is output voltage by the feedback resistance RF. Now substituting this equation 2, 3 in equation 1, we get this as minus V0 by RF. Now why do we find IF as equal to minus V0 by RF? Look back to the circuit. We know our IF is given by the expression VA minus V0 by RF, where from the virtual ground concept we know our VA VB would be equal to 0. When we substitute, I get my IF as equal to minus V0 by RF. So that is what is substituted here. So my IF would be equal to minus V0 by RF. So substitute 2, 3 and in equation 1 we get this. Once we substitute, start solving for the V0. My V0 would be equal to minus of RF by R1 into V1 plus RF by R2 into V2 plus RF by R1 into R3 into V3. Now if at all my all the resistances that is present here, that is R1, R2, R3 and RF are of equal in magnitude, and we substitute it as R, I get my output voltage expression as minus of V1 minus V2 plus minus of V1 plus V2 plus V3, which where my minus sign indicates it as a inverting summer, right? It is an inverting summer, and with all the summation of voltages that is present at the single node, correct? So it is nothing but my output voltage is given when V naught equal to minus of V1 plus V2 plus V3. So this is about your summer or the adder circuit. The output voltage of your summer circuit, summer is V naught is equal to minus of V1 plus V2 plus V3. Now let's move on to the subtractor circuit, where the subtractor is nothing but the name itself suggests we need two different voltages to subtract. As a result, we connect V1 and V2. So subtractor is a circuit whose output voltage will be potential to the difference between the two input terminals, that input voltage signals, that is V1 and V2, which is as shown here. So we have the currents as I1 and I2 and the feedback current as IF, right? So the input signals applied are V1 and V2, that is we are going to apply the input voltage for both the terminals, both inverting as well as the non-inverting. Now due to the virtual ground concept, the voltage at the inverting terminal is V and the current flowing through the resistance R1 and R2 are I1 and I2. Now first what we are going to do here is we are going to reduce the input voltage, that is the input voltage V2 to 0 to find out my output voltage V01. What we are doing, we are going to reduce the voltage V2, input voltage V2 to 0 and finding V01, that is the output voltage with respect to the input 1. Now once we do this, we know, since it is connected to the inverting terminal, we know our output voltage for the inverting terminal is given by V naught is equal to minus RF by R1 into V1, gain into voltage. My output voltage expression is V naught is equal to A into V. So what is my V? V across the inverting terminal is the gain. So minus gain is given by minus RF by R1. And what is the input voltage? V1, substitute. So we get V01 as RF by R1 into V1. Now similarly, let us reduce our V2 voltage as equal to V2 is equal to 0 and V1 is equal to 0, and let's find out V02. So when we find out V02, I can say now the input is applied for the inverting terminal. So this is my inverting terminal. Now the input is applied to my inverting terminal. Now as a result, I can say my output voltage is V0 is equal to A into V, where A is nothing but an inverting amplifier. Non-inverting amplifier gain is given by 1 plus RF by R1 into V, where V is nothing but my input voltage V2, substitute. So let's solve for V02. When V02 is equal to, with all the substitution, I can say it is RF by R1 into V2. Now let's add V01 and V02. So when we add V01 and V02, I can say my V01 is minus RF by R1 and my V02 is plus RF by R1. So this is my V1 and this is my V2. Now what is going to happen? My RF and R1 is going to get cancelled. When I take common, I will be getting my V0 as equal to minus RF by R1 into V2 minus V1, where if the resistance R1 is equal to RF is equal to R, then I can say my V0 voltage is equal to V2 minus V1, which is nothing but the difference of the two voltages that we have applied across the subtractor operational amplifiers. So this is what is the expression for your subtractor circuit. Now moving on to the voltage follower. The name itself suggests the output voltage is going to follow the input. So no matter whatever might be my input, that would be followed as my output. So when we look into the circuit, we have the feedback element replaced. That is, we are going to short directly the output voltage to the input inverting terminal input. Observe here, we are going to short without the feedback element the output voltage to the inverting input terminal V2, and we are going to give the power supply to the we are going to apply the input voltage to the V1. Now once we apply it, I can say as the input signal is connected directly to the non-inverting input of the amplifier, the output signal is not inverted since it is a non-inverting input, right? So it is not inverted, resulting in the output voltage being equal to the input voltage. So my V out would be equal to V in. Since I don't have any feedback resistance, I can say my V out as equal to V in. Now as a result, the gain across this voltage follower is equal to unity. That is, my output voltage is equal to V in. V out is equal to V in. As a result, I can say the voltage follower is going to provide us a unity gain. Now let us see how this is possible. Now what is the output voltage expression given by V out is equal to V naught is equal to A into V in, that is gain into input voltage. Now we know our V in is equal to plus volt and V out is equal to minus V. From the V in is equal to plus 1 and V naught is equal to minus V2 because it is connected to the inverting terminal. So substitute that plus V and minus V. So we get our gain AV as equal to, what is the gain? Output by input substituted. So minus and plus V gets cancelled and we get this as equal to 1. Always my voltage follower is a circuit where this is going to provide us a unity feedback. Now once we say with the virtual ground concept, we can say our V2 is also equal to V1. Therefore, I can say my V0 is equal to V in. So, I can say the output follows the input. As a result, the name of the circuit is kept as voltage follower. So, these are the contents that, these are the links and these are the various, these are the various content where we came across during the slide preparation. Hope this video is very useful for your knowledge and for your beneficiary. Thank you for watching this video.